All right, everybody, let's turn to page 437. It says, Marianne orders a pack of shipping boxes shaped like cubes. When they arrive, she finds flat pieces of cardboard as shown. What is the least amount of cardboard needed to make each box? All right, so what we're going to do is we're going to find the surface area, as we call it, of each cube. So it's 9 by 9, so this is 81, this is 81, 81, 81, 81, 81, and those are square inches because it's area. So we can do one of two things. We can add 81 6 times, or we can just multiply it by 6. I'd prefer to multiply it by 6. So we get 6. So 486 inches squared is what our surface area would be for the cubes, and this is what we're looking at today. All right, let's turn to page 438 for example 1.
How can you find the surface area of a prism? Think about this question during the lesson. Kelly wants to cover a shoebox with decorative paper to make a storage box for her photos. How much paper will she need to cover the box? You can use tools to draw a net to help you find the surface area of a solid figure. How might grid paper help you solve this problem?
Well, this way we can draw out it using the dimensions, and we'll look at the net like we did in the previous days.
You can use grid paper to draw a net of the shoebox. What type of figure is the shoebox?
Well, this is a rectangular prism. All right, it's definitely not a pyramid.
The shoebox is a rectangular prism. How many faces does the shoebox have? And what shape are they?
All right, well, we have a total of 6 faces, all of which are rectangles, and they're not all different sizes, though.
The shoebox has 6 faces. The faces are rectangles. Here is one way to solve the problem. Draw a net of the shoebox.
Okay.
Find the area of each face.
Now, we may not always have the option to do that, so with this formula, which I will provide a sheet for you, you could do this.
Then add the areas. Kelly needs 376 square inches of paper to cover the box. Which, if any, of the area calculations are repeated? Explain.
Well, we have the top and the bottom, the front
There
and
are
the back.
3 pairs of repeated calculations because the front and back of the shoebox have the same dimensions, as do the top and bottom and both sides. Here is another way.
All right, now this way is the way that we could do it using the formula sheet that I provided, as I said
A
before.
formula to find the total surface area, SA, of the shoebox. Kelly needs 376 square inches of paper to cover the box.
All right, let's look at this, try it. So they're giving us the way of doing it using the net. Like I said, we're going to try and do it both ways, though. So we see that we have this, which is 8, and this is 8, okay? So those repeat. We have this, which is 12, and this is which is 12. Those repeat. Then we have this, which is 6, and this is which is 6. So we could do 6 plus 6, 8 plus 8, 12 plus 12. All right, we have doubles, as we can see, resulting in a total of 52 centimeters squared. Remember that you have to have those. All right, let's turn over to page 439 to look at example 2. It says Sam built a storage cube out of plywood. How many square meters of plywood did Sam use for the cube? Well, the nice thing about a cube is that we know that the lengths and widths are the lengths and heights or lengths and widths are the same. So we could do 0.5 times 0.5, right, which would result in 0.25, and then we can multiply that by 6 since we know there's 6 equal faces, all right? That's what they show here. They're using a formula 6s squared, meaning side squared. All right, 6 times 0.25 ends up being 1.5. So the total surface area for this cube is 1.5 meters squared. All right, everybody, let's turn to page 439 in our books. It says, find the surface area of the triangular prism. So what they do is, and this is an option as we talked about, is that you can look at the net, basically the unfolded version of this prism, which they do here. We see that we have 3 different types of rectangles and then 2 triangles on top and bottom that are similar. As we go through, we find the area for each one. All right, and then we can see that we add them all together. There's 2 triangular bases, that's why it's multiplied twice. And then we have our rectangles giving us a combination of 756 centimeters squared. Right, so if we look at this one, what's nice about the cube is that a simple formula is 4.2 squared, or 4.2 times 4.2 times 6. And I say 6 because there are 6 faces. So let's grab a calculator here and take a look at that. And it should be, without rounding it off anywhere, is 105.84 centimeters squared. And because we're talking about area, we're going to square it. So here I'll draw the net of this particular shape. It kind of looks like a tent. All right, not the prettiest drawing, but we got 6, 7. We know our height is 4. Let's see that this is 5. All right, this is 5. This is 7. This is 7. This is 5. This is 5. All right, so let's do the triangle. 6 times 4 is 24. There's 2 triangles, so we don't necessarily have to cut that in half. And then we have 7 times 5, which is 35. Right? There's 2 of those, so we'll multiply it by 2. And then we have this portion in the middle, which is 6 times 7. So this is 6 times 7, which is 42. We add that all together, so we got 24 plus 70 plus 42 should give us a total of 136 feet squared. So make sure that's written in for page 439.